Okay, so how does the world we know, solid, predictable, normal, somehow bubble up from the completely bizarre rules of quantum mechanics? Well, there's this fascinating idea called quantum Darwinism that has an answer. And it suggests that reality isn't just a given, it's something that has to be earned. It all kicks off with a mystery that we take for granted every single second of every day. You and I can look at the exact same thing and agree on what it is and where it is. Seems totally obvious, right? But from a quantum point of view, that's a really deep puzzle. And it's a puzzle because that shared reality, the absolute bedrock of our entire experience, it actually flies in the face of what quantum mechanics tells us should be happening. Let's just take a simple coffee mug on a table. When you look at it, a bunch of photons bounce off of it and into your eyes. When I look at it, a totally different set of photons hits my eyes. We are making two completely separate, totally independent measurements of that mug. So if every single glance is its own unique, random quantum event, why isn't reality just a complete chaotic mess? How do we always agree that, yup, the mug is right there? This is the exact problem that quantum Darwinism was built to solve. And the solution, which was dreamed up by the physicist Wojciech Zurek, has this brilliant twist. It borrows its core logic from biology. The idea is that reality itself is the outcome of a cosmic natural selection. The whole thing boils down to one incredibly powerful word: redundancy. The reason you and I agree on where that mug is, it's because that information isn't just sent to our two sets of eyes. Oh no, it is broadcast, copied, and pasted billions upon billions of times into absolutely everything around it. And just think about how many copies we're talking about. The mug's position gets stamped onto the photons hitting our eyes, sure, but also the photons hitting the walls, the air molecules that are constantly bumping into it, even the tiny, tiny deformation of the table it's sitting on. The environment is basically acting like a giant public hard drive, and everyone can access it. But hold on, that brings up another question, right? Why is a property like position copied so perfectly? Why not the really weird quantum stuff, like an object being in a superposition, in two places at once? Well, it turns out not all information is created equal. Some properties are just fitter. They're better at surviving. And this is the absolute heart of the idea. It's literally natural selection, but for reality itself. The fittest quantum states, the ones that are the most stable, are the ones that manage to survive by imprinting countless copies of themselves onto the world. And those are the states we end up calling classical, or just real. So you can picture it like this. You have the fit states, like an object's position. They are tough, they are stable. When the environment interacts with them, they successfully reproduce their information over and over again. Then you have the unstable states, like a superposition. The second the environment even looks at them, their information gets scrambled into gibberish. They fail to reproduce, and from our point of view, they basically go extinct. Now, this isn't just some nice story. There's some really deep math that explains why this selection process happens. And it's described by something called the master equation, which reveals the blueprint for reality. You can think of this equation as laying out the rules for the game of survival. It describes this abstract geometric landscape, and it's on this landscape that the competition to become real actually takes place. So, in this picture, a stable state, like the position of our mug, is like a perfectly solid, balanced shape. When the environment interacts with it, boom, it creates clear, perfect copies of itself. It successfully reproduces. But an unstable state? It's more like a fragile, wobbly shape. The environment tries to copy it, and the information just gets garbled and lost. It's like trying to photocopy a ghost. You're left with nothing, no coherent copies for us to ever see. So let's break that down. First, these fit states are what physicists call stable centroids. Just think of them as stable centers of gravity. Second, the environment acts like a projector, and it beams images of these stable centroids out into all its different parts. That's reproduction. Third, redundancy is just a count of how many good, clear copies were made. And finally, a state's fitness is all about how well its geometry is aligned to make sharp, clear projection. So this geometric way of looking at it gives us a much deeper mechanism. What physicists used to call pointer states are really just these stable centroids. What we call redundancy is really just the reproduction of that centroid structure. And the reason we all agree on things? It's because we're all just sampling copies made from the exact same geometric blueprint. And what's so wild is that this comparison to Darwin isn't just a loose metaphor, it's a shockingly precise analogy. The quantum states are the organisms. Copying their information into the environment is reproduction. Their fitness is their geometric stability. And the master equation? Those are the laws of natural selection. The winners, the classical states we see all around us, are simply the dominant species of reality. I know this all sounds pretty out there, but this isn't just a cool thought experiment. It's actually been tested in laboratories, and its implications are they're completely mind-bending. They change how we have to think about reality itself. Yes, so over the last 10 years or so, scientists have been running these incredibly clever experiments that have confirmed the key predictions of quantum Darwinism. For instance, they've used tiny defects in diamonds as little quantum systems and have literally watched this process happen in real time, seeing the environment select for the most stable states and broadcast them. These experiments are taking this theory from a cool idea to an observed fact. So this whole thing completely reframes our understanding of the world. The objective reality we experience isn't some fundamental thing that's just there. It's an emergent property. It's something that has been earned by surviving this intense cosmic process of natural selection. This also totally changes our role in the universe. You know that old weird idea in quantum mechanics that an observer creates reality just by looking at it? This theory says, nope, that's not what's happening. We're actually much more passive. We're just readers. We're accessing one of the billions of copies of information that the environment has already selected, copied, and stored for public view. There's this one quote from the research that just summarizes the whole thing perfectly. Classical physics is the fossil record of quantum natural selection. I mean, come on. The stable, predictable world we see is just the fossil record, showing only the survivors of a much bigger, much stranger, invisible quantum competition. And that leaves us with a final, really provocative thought to chew on. If our reality is made up of just the tiny fraction of quantum states that won the reproductive lottery, what about all the states that failed? What vast, invisible quantum world are we not seeing simply because it never managed to leave a fossil behind for us to find?